Everything you think you know about who won the air war in World War II is probably wrong. Yeah, I said it. We've been told the same story for decades. America and Britain built superior fighters, Germany fell behind, and the good guys dominated the skies until victory. Clean narrative, right? Except here's the uncomfortable truth nobody wants to talk about. In 1944, Germany was actually winning the technology race. Their secret fighters were faster, more advanced, and more lethal than almost anything the Allies had. Some German aircraft were so far ahead that when American engineers finally got their hands on captured planes, they couldn't believe what they were seeing. So how did the Allies turn the tide? The answer isn't what your history teacher told you, and it's way more fascinating than you'd imagine. Here's what really happened, and stick with me because this is going to challenge everything you thought you knew about aviation history. The fastest fighter of WWII wasn't supposed to exist. It was born from a desperate race where nations threw everything they had into creating machines that could fly faster than anything humanity had ever built. We're talking about engineering pushed so far beyond its limits that test pilots were literally gambling with their lives every time they took off. German pilots in their advanced Luftwaffe fighters, American defectors who brought secret technology across enemy lines, incredible stories of innovation happening while bombs fell on the factories building these machines. This was the real war, and it was happening 30,000 feet above the ground where most people never saw it. Now, I know what you're thinking. Another WWII documentary about planes. Big deal. But here's why you need to pay attention to this true story. The aircraft we're about to discuss didn't just change who won the war, they literally created the foundation for everything that flies today. Every commercial jet you've ever flown on, every fighter jet protecting our skies right now, every principle of modern aviation, it all traces back to this moment in war history when engineers were locked in a race that would determine the fate of civilization. And the wildest part? Most people have no idea this race even happened, let alone how close Germany came to actually winning it with their jet fighters and radical designs that seemed impossible. You want to know the real secret? The difference between victory and defeat in World War II skies came down to a handful of machines that pushed piston engine technology to its absolute breaking point. We're going to walk through this journey together. From Germany's high-speed hunters that terrorized Allied pilots, to Britain's elegant killers that fought back, to America's raw power that overwhelmed everything in its path. And finally, we'll reach the ultimate achievement. A fighter so perfect, so refined, that it literally represented the end of an entire era of aviation. By the time we're done, you'll understand not just what happened, but why it matters to your life right now, today, in ways you never expected. And to stay up to date on everything, take advantage and subscribe to this channel now. Picture this. It's 1944, and somewhere over war-torn Europe, a young pilot pushes his aircraft to its absolute limit, knowing that just 1 extra mile per hour might be the difference between going home or becoming another name on a memorial wall. That's not Hollywood drama. That's the true story of what happened every single day during World War II. Nations weren't just fighting with guns and bombs anymore. They'd entered an invisible war that raged 30,000 feet above the ground. The stakes? Whoever controlled the skies would control the outcome of the entire conflict. And believe it or not, this aerial chess match would end up changing aviation history forever. Now, here's something most people don't realize about WWII. The war wasn't won just on beaches or in trenches. Nope, the real game changer was happening in the minds of engineers locked away in secret hangars, scribbling calculations that would either save their nations or doom them. Think about it. Every country involved knew that air supremacy meant everything. You could have the best tanks, the bravest soldiers, the smartest generals, but if enemy fighters ruled your skies, you were finished. So what did they do? They threw everything they had into creating machines that could fly faster, climb higher, and hit harder than anything the enemy could field. It became an obsession, really, and that obsession gave birth to some of the most incredible aircraft ever built. Let's talk about what actually drove this insane race for speed. See, early in the war, both sides figured out pretty quickly that whoever got to the fight first usually won. Sounds obvious, right? But here's the twist. Getting there first wasn't just about courage or tactics anymore. It was about raw physics and engineering genius. The Luftwaffe in Germany, the RAF in Britain, and American aviation engineers all came to the same conclusion independently. Piston engines had to be pushed beyond what anyone thought possible. We're talking about squeezing every last drop of performance from technology that, honestly, was already at its breaking point. Engines were running so hot they'd sometimes literally tear themselves apart mid-flight. You know what's fascinating? The pressure cooker of war history created innovation at a pace we've never seen since. Designers who'd normally spend years perfecting a single aircraft feature now had months, sometimes weeks, to get it right. Picture a German engineer in 1944, working 16-hour days, knowing that Allied bombers are getting closer every night, and the fighter he's designing might be the only thing standing between his country and total defeat. That kind of desperation breeds brilliance. It's the same principle you see today when tech companies race to launch the next breakthrough product, except back then, losing the race meant losing everything. Literally everything. Here's where it gets really interesting, and this is something aviation experts still marvel at today. The piston engine fighters developed in the final years of WWII represented the absolute peak of what propeller-driven aircraft could achieve. They were so refined, so perfectly engineered, that we've never actually surpassed them in that specific category. Sure, we moved on to jets, but that's a different game entirely. These wartime birds were like watching an Olympic sprinter break the world record. They touched the ceiling of what was physically possible. German aircraft like the ones we'll discuss, British fighters that chased down German secret weapons, and American powerhouses that could escort bombers all the way to Berlin and back, they were all symptoms of the same fever dream. But let's get real for a second. Behind every incredible story of technological achievement, there were human costs most history books gloss over. Pilots barely out of their teens climbing into cockpits of experimental fighters that might disintegrate at top speed. Engineers working themselves to exhaustion, knowing that every calculation error could cost hundreds of lives. Factory workers, many of them women, riveting together war machines while bombs fell on their cities. The race for aviation supremacy wasn't some clean, academic competition. It was brutal, desperate, and unforgiving. Each new fighter that rolled out represented thousands of hours of sweat, fear, and sacrifice. And here's the kicker that'll blow your mind. This wasn't just about winning the war. What these engineers and pilots were really doing, without even knowing it, was writing the blueprint for everything that came after. Commercial aviation, space exploration, modern military aircraft. They all traced their DNA back to those frantic years when the world was tearing itself apart. The German pilot who defected with cutting-edge technology, the captured planes that ended up in American hangars being reverse-engineered, the desperate innovations born from fuel shortages and material scarcity, all of it fed into a knowledge base that would transform human flight forever. But to understand just how revolutionary these machines were, we need to look at the German aircraft that made Allied commanders lose sleep at night. Let's talk about something that genuinely terrified Allied pilots in 1944. Machines that seemed to come from the future. While American and British engineers were refining what they already had, the Luftwaffe was birthing something entirely different. The FW-190D9, affectionately called Dora by German pilots, and the Ta-152H weren't just incremental improvements. They were radical reimaginings of what a fighter could be. These German aircraft represented a level of engineering sophistication that made Allied intelligence officers break out in cold sweats when they first studied captured planes. Here's the wild part. These weren't designed in peacetime laboratories with unlimited resources. No, they were conceived and built while Germany was literally crumbling, with Allied bombs falling on the very factories producing them. Think about the pressure cooker situation those German engineers faced. Kurt Tank, the genius behind these designs, was essentially told, "Hey, we're losing the war, our pilots are being shot down daily, and we need something that can outperform anything the Allies have. Oh, and you've got almost no time and fewer resources." Talk about a tall order, right? But here's where desperation meets brilliance. The FW-190D9 took the already formidable 190 airframe and stretched it, adding a Junkers Jumo 213 inline engine that transformed it into something altogether more sinister. Pilots who flew it said the thing felt like a caged predator, all coiled muscle ready to explode. At around 426 miles per hour in level flight, it could catch just about anything in the sky and, more importantly, choose when to fight and when to run. Now, here's an incredible story that'll show you just how revolutionary these machines were. Picture a young Luftwaffe pilot scrambling to intercept a formation of American B-17 bombers escorted by P-51 Mustangs, the pride of the U.S. fighter fleet. In the old FW-190 models, he'd struggle at high altitude where the air gets thin and those radial engines gasped for oxygen. But in the Dora, completely different ballgame. That inline engine with its advanced supercharger meant he could climb faster, fight higher, and actually challenge the Mustangs on more equal terms. Allied pilots who'd grown confident in their superiority suddenly found themselves in knife fights they weren't expecting. Some even reported encounters where they swore they'd engaged early jet fighters, only to later discover they'd been dueling with these advanced, piston-engine German aircraft. But the real crown jewel, the aircraft that represents the absolute pinnacle of Luftwaffe piston-engine design, was the Ta-152H. And listen, when aviation historians talk about this bird, they get this distant look in their eyes like they're describing a mythical creature. Because in many ways it was designed specifically for extreme high-altitude interception. This thing could operate effectively above 40,000 feet where most fighters of WWII simply couldn't function. We're talking about a war machine that could hit 472 miles per hour in the thin air where American bomber formations thought they were safe. The wingspan was extended, the cockpit was pressurized, and every single component was optimized for performance in an environment that would choke other engines to death. Germany had created a high-altitude hunter unlike anything the world had seen. Here's what blows my mind about this whole chapter of war history. These incredible achievements were happening while Germany was falling apart at the seams. Imagine trying to build the most advanced fighter in the world while your fuel refineries are being bombed into rubble, your experienced pilots are mostly dead, and your factories are staffed by exhausted workers on starvation rations. The Ta-152H and FW-190D9 weren't just engineering triumphs. They were acts of almost delusional determination. German engineers knew they were racing against an inevitable clock, yet they pushed forward anyway, refining, testing, perfecting. It's like watching someone meticulously organize their desk while the building burns down around them. Except in this case, that obsessive focus actually produced masterpieces. But here's the tragedy that doesn't get talked about enough in your typical war documentary. These phenomenal aircraft arrived too late and in too few numbers to change Germany's fate. By late 1944, the Luftwaffe was hemorrhaging experienced pilots faster than they could train replacements. You could have the fastest, most maneuverable fighter in the skies, and the Ta-152H arguably was, but it meant nothing if the kid flying it had barely 30 hours of training and no fuel to practice combat maneuvers. Allied pilots would later describe encountering these advanced German fighters flown so clumsily that they became easy prey despite their technical superiority. It's a sobering reminder that in warfare, the human element always trumps the technical one. The best tool in the world is useless in untrained hands. And here's where things get really interesting for America and the future of aviation. When the war ended, Allied forces rushed into Germany like kids on a treasure hunt, desperate to capture these secret fighters before the Soviets got them. Intact examples of the FW-190D9 and the precious few Ta-152H models that existed became intelligence goldmines. American and British engineers crawled over every inch of these captured planes, documenting every innovation, every clever solution to problems they were still struggling with. Some German pilots, seeing the writing on the wall, actually became defectors, flying their advanced aircraft to Allied airfields and spilling everything they knew. The knowledge extracted from these machines, the aerodynamic refinements, the engine management systems, the high-altitude optimization techniques, all of it flowed directly into post-war aviation development. But while these piston-engine marvels represented the peak of one era, the British were already writing the next chapter with their own speed demons. So while Germany was pushing the boundaries of what piston engines could do, Britain wasn't exactly sitting around drinking tea and hoping for the best. The British had something that Germany was rapidly losing: time, resources, and an island that, while battered, remained unconquered. And boy, did they use those advantages. Enter two machines that would become legends of WWII aviation: the Hawker Tempest V and the Supermarine Spitfire Mk-14. These weren't just fighters. They were Britain's answer to every challenge the Luftwaffe threw at them. What's incredible about these aircraft is how they perfectly embodied British engineering philosophy: elegant, refined, but absolutely brutal when the situation demanded it. They represented a different approach than the German aircraft, one that balanced raw speed with reliability and tactical versatility. Here's a true story that'll give you chills. Summer of 1944, and Hitler's unleashing his vengeance weapons, the V-1 flying bombs, on London. These early cruise missiles were terrorizing the civilian population, and conventional anti-aircraft fire was struggling to stop them. The V-1s flew fast and low, around 400 miles per hour, which put them just beyond the reach of most RAF fighters. But not the Tempest V. This beast, powered by a massive Napier Sabre engine producing over 2,400 horsepower, could hit 435 miles per hour in level flight, fast enough to chase down these robot bombs and either shoot them down or, get this, use its wingtip to flip them off course. Pilots like Wing Commander Roland Beaumont became V-1 hunting specialists, racking up dozens of kills against these weapons. Imagine the skill required, flying at near maximum speed, just feet above the ground, lining up a small, fast-moving target that could explode at any second. Now, let's talk about why the Tempest V was such a revelation in war history. See, earlier Spitfire models, while phenomenal, struggled a bit at low altitude where thicker air robbed them of their high-altitude grace. The Luftwaffe knew this and started operating their new Focke-Wulf fighters in low-level hit-and-run attacks where they had the advantage. The RAF needed something that could dominate down in the weeds where dogfights got dirty and personal. The Tempest was that answer: thick wings, powerful engine, and a heavy armament of 420mm cannons that could absolutely shred German aircraft. When Tempest squadrons started hunting FW-190s along the European coast in 1944, the tables turned dramatically. Suddenly those German pilots who'd been having their way found themselves being hunted by something faster and meaner than they'd expected. But here's where British engineering really showed its genius. They didn't put all their eggs in one basket. While the Tempest was being optimized for low-altitude work, Supermarine was taking their legendary Spitfire design and giving it a serious shot of adrenaline. The Spitfire Mk14 mounted the incredible Rolls-Royce Griffon engine, a power plant that produced 2,050 horsepower and transformed the graceful Spitfire into an absolute rocket ship. This thing could hit 448 miles per hour and climb to 20,000 feet in just over 5 minutes. Allied pilots who transitioned from earlier Spitfire models to the Mk14 said it felt like upgrading from a sports car to a drag racer. The same elegant handling they loved, but with performance that could challenge anything the Luftwaffe fielded, including those fearsome FW-190D9S and Ta-152s we talked about earlier. Here's what's fascinating about the Spitfire Mk14 from an aviation perspective. It represented the ultimate evolution of a design that first flew in 1936. Think about that for a second. The basic DNA of this aircraft was nearly a decade old by 1944, yet through continuous refinement and upgrading, it remained competitive against brand new German designs. It's like if someone took a car from 2015 and through careful modifications made it outperform 2024 models. That's the power of getting the fundamentals right from the beginning. R.J. Mitchell's original Spitfire design was so aerodynamically sound, so perfectly balanced, that it could absorb massive increases in power and weight without losing its essential character. German pilots learned to respect the Mk14 quickly. Those who often didn't get a second chance to learn. Now here's a practical example of how these British fighters changed the tactical landscape of World War II. During Operation Market Garden in late 1944, Tempest squadrons provided air cover for the ill-fated Allied airborne operation. Their job was to maintain air superiority and prevent Luftwaffe fighters from attacking the vulnerable transport aircraft and gliders. Despite the operation's ultimate failure on the ground, the Tempests absolutely dominated the skies, shooting down numerous German aircraft attempting to interfere. One pilot, squadron leader Dave Fairbanks, described engaging a formation of FW-190s and being struck by how his Tempest could not only keep up but actually outperform them in the climb and turn. The confidence that gave Allied pilots was immeasurable. They were no longer worried about being outclassed by secret German technology. But here's the thing about Britain's aerial response that often gets overlooked in the incredible story of WWII aviation. While the Tempest and Spitfire Mk14 were phenomenal aircraft, they still represented the refinement of existing concepts rather than revolutionary leaps. Britain was playing it smart, taking proven designs and maximizing their potential rather than gambling on entirely new configurations. It was a conservative approach, but one that made perfect sense given Britain's strategic position. They needed reliability, they needed numbers, and they needed pilots to transition smoothly between aircraft types. And this philosophy worked brilliantly for the European theater. But across the Atlantic, America was taking a different approach. One that combined British elegance with sheer American audacity and industrial might, creating fighters that would push the boundaries even further. Let me tell you something about American engineering during World War II that perfectly captures the national character. When they entered the fight, they didn't just want to compete, they wanted to overwhelm. And nowhere was this philosophy more evident than in their fighter aircraft development. While Britain refined elegance and Germany pushed the limits of desperation-fueled innovation, America brought something entirely different to the table. Industrial muscle combined with a go big or go home mentality. The result? Machines like the Grumman F-8F Bearcat and the Republic P-47M Thunderbolt that didn't just match their opponents. They redefined what American aviation could achieve. These weren't subtle aircraft. They were statements of intent, built by a nation with the resources to turn audacious ideas into flying reality. Now, here's where things get really interesting in this chapter of war history. The F-8F Bearcat was actually designed with one specific enemy in mind, and it wasn't Germany. By 1943, American naval planners were looking at the Pacific theater and realizing that Japanese fighters like the Zero were running circles around heavier American aircraft in turning fights. So Grumman's engineers asked themselves a radical question. What if we took the most powerful engine we could find and wrapped the smallest, lightest airframe possible around it? The result was borderline insane. A fighter that weighed just 7,070 pounds empty, but packed a 2,100 horsepower Pratt & Whitney R2800 engine. The power-to-weight ratio was absolutely ridiculous. This thing could climb at over 4,500 feet per minute and reach 455 miles per hour, making it one of the fastest piston engine fighters America ever produced. Here's a true story that shows you just how revolutionary the Bearcat was. A test pilot named Corky Meyer flew the prototype and later described the experience as strapping a rocket to your back. The acceleration was so violent that pilots had to be careful not to firewall the throttle during takeoff or the torque would literally flip the aircraft. But here's the kicker, the Bearcat arrived too late to see combat in WWII. The war ended before it could be deployed in significant numbers. Does that mean it was a failure? Not even close. That incredible design became the foundation for post-war naval aviation and dominated air racing for years. It proved that American engineers could create fighters as nimble as anything Japan or Germany fielded while maintaining the ruggedness and firepower that characterized American aircraft. It was a glimpse of what American aviation could achieve when they stopped playing catch-up and started innovating. But let's talk about the aircraft that actually did see combat and became an absolute legend, the Republic P-47M Thunderbolt. Now, the regular P-47 was already known as the Jug because it looked like a flying milk jug, big, bulky, and seemingly too heavy to be graceful. But American pilots loved it because the thing was virtually indestructible and packed 8.50 caliber machine guns that could saw an enemy aircraft in half. The M model, though? That was Republic Aviation saying, "You think the Thunderbolt is just a tough ground attack plane? Watch this." They fitted it with a souped-up R2800 engine with water injection that produced 2,800 horsepower for short bursts. The result was a 7-ton fighter that could hit 470 miles per hour, fast enough to chase down Germany's secret fighters and even some early jets. Here's what blows my mind about the P-47M, and this is something aviation experts still marvel at today. In early 1945, the Luftwaffe was using hit-and-run tactics with their fastest aircraft, including the jet-powered Me-262s, to attack Allied bomber formations. Traditional escorts struggled to catch these raiders. So America deployed the 56 Fighter Group equipped with P-47MS specifically to hunt these high-speed threats. And you know what? It worked. These Thunderbolts, despite their bulk, proved fast enough and tough enough to tangle with just about anything Germany threw at them. There's documented accounts of P-47MS actually catching Me-262 jets during their vulnerable moments, takeoff, landing, or when the jets were slowing down to attack bombers. Imagine being a German pilot in your futuristic jet fighter and seeing this massive American piston engine aircraft keeping pace with you. Must have been demoralizing. Now, here's where we need to talk about something absolutely wild from the German side that emerged during this same period, the Dornier Du 335 file, or Arrow. This aircraft was so bizarre, so unconventional, that when captured examples reached America after the war, engineers couldn't quite believe what they were seeing. Picture this, a fighter with two engines, one in the nose pulling and one in the tail pushing, giving it a centerline thrust configuration that eliminated the torque problems that plagued single-engine fighters. This thing could hit 474 miles per hour, making it potentially the fastest piston-engine aircraft of WWII. It was a German secret weapon that represented thinking so far outside the box that the box wasn't even visible anymore. But like so many late-war German aircraft, it arrived too late and in too few numbers to matter strategically. The WWII story is actually pretty tragic when you dig into it. Here was this incredible piece of aviation technology. Fast, well-armed, innovative, but it was born into a dying regime that couldn't fuel it, couldn't produce it in meaningful numbers, and couldn't train pilots to fly it effectively. American intelligence officers who studied captured planes after the war were simultaneously impressed and relieved. Impressed because the engineering was genuinely groundbreaking, and relieved because if Germany had developed this even 2 years earlier with adequate resources, it could have been a real problem. The technical knowledge from the WWII, along with data from captured German aircraft and defector pilots who brought their secrets west, fed directly into American post-war aviation programs. But while these fascinating machines represented the peak of conventional thinking, America was about to unveil something that would render this entire conversation almost obsolete. A piston-engine fighter so refined, so perfectly executed, that it touched the absolute ceiling of what propeller-driven flight could achieve. So we've talked about German desperation engineering, British refinement, and American industrial might, but now we need to discuss the aircraft that basically said game over to the entire piston-engine era. The North American P-51H Mustang wasn't just another fighter. It was the final word in a conversation that had been going on since the Wright brothers first lifted off at Kitty Hawk. This machine represented the absolute pinnacle, the ultimate achievement of propeller-driven flight. When you look at aviation history, there's a clear line. Everything before the P-51H was building toward it, and everything after was moving beyond it into the jet age. At 487 miles per hour in level flight, weighing just 6,585 pounds empty, and possessing handling characteristics that made experienced pilots weep with joy, this was perfection wrapped in aluminum and rivets. Here's the incredible story of how this masterpiece came to be. North American aviation had already created a legend with the earlier P-51D Mustang, the fighter that escorted American bombers all the way to Berlin and back, breaking the Luftwaffe's back in the process. But by late 1944, engineers looked at combat reports and asked themselves a crucial question. What if we made it lighter, faster, and even more lethal? They went to work like sculptors, removing everything that wasn't essential, shaving weight from every component while strengthening the airframe and boosting the engine output. The result was an aircraft that climbed 20% faster than the already impressive D model, turned tighter, and could outrun virtually anything in the sky. Test pilots who flew it reported that the H model felt like the Mustang had been holding its breath for years and finally exhaled. Now, let me give you a practical example of just how dominant this aircraft was. Picture a formation of B-29 superfortresses preparing for missions against Japan in 1945. These massive bombers needed escort fighters that could keep up with their 350-plus mph cruise speed, fight off interceptors, and still have enough fuel to make the incredibly long-range missions. Earlier fighters struggled with this mission profile. They either lacked the speed, the range, or the high-altitude performance needed. The P-51H checked every single box. It could cruise efficiently at high speed, climb rapidly to intercept threats, dogfight with anything it encountered, and return home with fuel to spare. When the first P-51H units began deploying to the Pacific Theater, American bomber crews breathed easier knowing they had the absolute best guardian angel technology could provide. But here's what's truly mind-blowing about this chapter of war history. The P-51H was so advanced that it barely saw combat in WWII. Just like the Bearcat, it arrived in the final months of the war when Japan was already collapsing and Germany had surrendered. Does that diminish its significance? Not even remotely. This aircraft represented the accumulation of everything learned from 6 years of brutal aerial warfare. Every lesson from dogfights over Britain, every insight from captured German aircraft, every innovation from defector pilots who brought their knowledge to America, every incremental improvement to engine technology and aerodynamics. All of it converged in this one perfect machine. It was like watching a master chef create the ultimate dish using techniques refined over decades. Here's something aviation enthusiasts still debate today. Could the P-51H have caught the German jet fighters that were terrorizing Allied bomber formations in early 1945? The answer is nuanced and fascinating. In straight-line speed, jets like the Me-262 had the advantage, hitting speeds around 540 miles per hour. But here's the thing about those early jets: they were temperamental, had limited endurance, and were extremely vulnerable during takeoff and landing. The P-51H was fast enough and had enough climb performance to patrol the approaches to German jet airfields and catch them in those vulnerable moments. There are reports of regular P-51D Mustangs doing exactly this. The H model would have been even more effective. Plus, in turning fights, the jets bled energy quickly, while the P-51H could sustain high-G maneuvers that would force a jet pilot to disengage or crash. Let's talk about what this aircraft meant for America and the future of aviation. When the war ended, the P-51H became the benchmark against which all future piston engine fighters were measured, and essentially none surpassed it in the pure fighter role. Sure, there were specialized aircraft that did specific things better, but as an overall package of speed, range, maneuverability, and combat effectiveness, the H model stood alone. Post-war, many were converted for air racing, and they dominated competitions for decades. Some are still racing today, 75 years later, which tells you everything about how fundamentally sound the design was. The Korean War saw Mustangs return to combat, though by then they were primarily used for ground attack while jets handled air-to-air combat. The era had shifted, and here's the profound truth that we need to sit with for a moment. The P-51H Mustang marked the end of an incredible journey that began with fabric-covered biplanes barely able to reach 100 miles per hour and ended with sleek, powerful machines approaching 500 miles per hour. In just 30 years, aviation had evolved from a novelty to an art form, pushed forward by the brutal necessities of two world wars. The quest for speed that drove nations to pour resources into these magnificent machines had reached its natural conclusion. Piston engines, propellers, and brilliant aerodynamic design had been pushed to their absolute limits. The roar of reciprocating engines that had defined aerial combat was about to be replaced by the scream of jets. But before we close this chapter, we need to understand what all of this really meant. Not just for war, but for everything that came after. So there you have it, the true story of how the desperate race for speed in World War II literally shaped everything flying today. These weren't just machines. They were the moment humanity touched the absolute limits of what piston engines could achieve before the jet age changed everything forever. Now, if this incredible story opened your eyes to aviation history you never knew existed, do me a favor. Smash that like button, drop a comment telling me which aircraft blew your mind the most, and where in the world you're watching this from right now. I'm genuinely curious if we've got viewers from Germany, America, Britain, or somewhere else entirely. And listen, if you thought the story was fascinating, you absolutely need to click that card appearing above and watch the next video. Trust me, what we're covering next will completely change how you see military history. Oh, and hit subscribe and turn on notifications, because we're just getting started uncovering the stories nobody else is telling. See you in the next one.